The topic of today's webinar is KUKA.Sim, and which is a simulation software where you can do offline programming and test your programs offline, and also optimize your operation of robots. This is how to ensure flexibility and productivity in the system. So you could do cycle time analysis and so on. So what's the purpose of KUKA.Sim and what aspects can we use it in? Well, it's a feasibility. It's a system where you could quickly and easily build, say, a cell layout, or in many cases you've designed a cell layout in some other CAD software, which then could be imported to KUKA.Sim to check, for example, if your robot has the reach required and the layout of the cell. You could also use KUKA.Sim as a sales presentation tool, if you like. You could create sales material. You could also use it for planning and checking cycle times, optimize cycle times, and so on. And last but not least, of course, we want to enable you to save time during your complete project, both on programming but also on commissioning in forms of virtual acceptance tests, for example, or debugging pre-FATS operations. So let's dive into that a little bit closer. We can use KUKA.Sim very easily to play us out a robot and a few obstacle hinders, if you like, and check the reach of the robot. It could look like something like this in a very simple layout. So here I just placed a robot and a few obstacles in the cell. I can now take hand of the tool and start moving the robot about. And you see that at some places an attention mark shows up. And this is, in this case, that a robot will, in this case, collide with an object here. And depending on how, it's a bit laggy when I'm running the webinar software at the same time. So this is a very simple check of reach and reachability, which I can use KUKA.Sim for. And instead of just placing, of course, I can have an extensive library of objects to place in, not only robots, but conveyors and so on are already in KUKA.Sim, but I can also import pre-designed objects from basically any CAD system that you may be using to design your cells or machine layouts. We can also use KUKA.Sim as a presentation tool to create our sales material or quotation material. So if I dive back into my KUKA.Sim and I go to another project, here I have a pre-designed cell with some functionality inside of it, but I've also already created a functional robot program and recorded a simulation so I can demonstrate the method of operation to a customer at a customer meeting, for example. And During the animation, I can actually zoom in to look at the operations in detail, if I like. So this is a very powerful presentation tool. But not only that, but I don't really need KUKA.Sim to do these presentations. I can actually export this 3D model and the simulation as, for example, a 3D PDF to provide to the customer. I can also generate layout drawings, (2D) drawings, and also create a bill of material. Kim has a question that he has tried this and usually imports step files used in layouts, but KUKA.Sim doesn't read the colors, so all my imported items become one-colored. Is there an importable CAD format which KUKA.Sim reads with colors as well? Actually, I believe there is an update to KUKA.Sim on its way to do this correct reading. So, and I haven't tried it in the latest version, which is 3.1.2 actually. So it could be that I think I read something, but I have to get back to you. I think if it's not fixed already, it's going to be fixed in a hotfix, which is allowing for the surfaces in the step file to present it in the right colors. And of course, if you don't want to use 3D PDFs, there is a 3D file viewer which you could create an animation for your mobile and show, or a pad. Or even if you have the availability, you could actually even walk around in your simulation with a VR set if you have access to these. So this is a very powerful way of presenting a concept, an idea of a cell to a customer. And as I mentioned before, we could use it for planning or simulation, checking a cycle time, for example, to ensure that a simulation movement is the exact movement and the time we require it to do. And this is a test we can do before we start commissioning the cell, which indeed saves us time and increase our availability. And the last time, how do we save time? Well, some of you perhaps is already doing it, some of you don't, but the topic of virtual commissioning and how to create it is a big talking subject amongst both customers and partners to us. And the idea is to get rid of all the bugs in a system before we actually start commissioning it, hereby both decreasing the time until we have a start of production and also decreasing the overall costs we will have. And I know that there is a big uncertainty among many of our customers. How is this actually done? What will they cost? What do I need to create this? And we will dive into this a little bit shortly here. But getting back to KUKA.Sim as a standalone project right now, just recapitalize a little bit. Who would benefit by using KUKA.Sim? Well, for sure, the construction department or the mechanics department would have great use of checking the layout of the cell, checking the robot movements to ensuring the reach, demonstrate the functionality. He could quickly create a layout in KUKA.Sim to show it take in a matter of minutes, or import a pre-designed layout from another CAD software. With looked a little bit closer at how it is a sales tool to create sales information for both quotation and presentation material, or even a proof of concept to a customer. For the programmers, well, there are obvious pros to use KUKA.Sim, where you can do offline creation of code and simulate the following without having actually the robot in place, hereby allowing you to actually buy and receive the robot later in the project. And you could also use it for a pre-FAT validation before you do a FAT with it together with the customer. Now, equally important is it actually for a service aspect. You could do customer training, educating a customer operator even before the cell is set up at all, actually, using KUKA.Sim. Ricky has a comment here. The price calculation for a cell is also better with the simulation because the tool, time, and other parts will be much more correct if the simulation is done before the price calculation. Very good input there. You use it as early as when you do a price calculation. Very good. And we talked to another customer who actually uses it all the time for the complete project team. At every project meeting, they bring up the 3D cell, the simulation of the cell, to ensure that everyone involved in the team has a clear understanding of the process, the functionality of the cell, and can also test the functionality and visualize it. And this brings us into the topic of virtual commissioning and the fact that a robot in itself is, in almost every case, not a standalone component, but it exists in a complete cell where usually it's PLC controlled with a lot of other equipment interacting with the robot on the cell. So how does KUKA.Sim actually fit into this puzzle? Now, I've worked at a system integrator for the past 6 years, so I've built a little bit of our own experience of how we should have had done in many cases, because we usually didn't do any so much simulation of testing of a cell before we actually installed it, which at the end of the day caused us high workloads, so to speak, during commissioning. We had a lot of discoveries during commissioning, which very often was not really necessary. And I've built my little reasoning example here on what we did usually. So we worked a lot with Siemens and KUKA robots. And using Siemens, that resulted that we created a PLC, an HMI code using a TIA portal, and programmed the robots either online after this robot was set up or in advance in Work Visual. What we then could do, but seldom did in the proper way, was to actually download the pre-designed code into virtual controllers. That is PLC.Sim. We used PLC.Sim somewhat, but that was rarely on a standalone base. Usually on a standalone base, not connecting it with a cell layout in total. And we could then use our virtual robot controller, KUKA Office Lite, which comes together with KUKA.Sim, to actually create the virtual cell controllers, both for robot and PLCs. To this, I then need the visualization to show the result of my simulation. The visualization usually was actually done with a physical operator panel to create an environment for an operator, a user, which was as real as possible. This physical operator panel could be directly coupled to these virtual controllers. and also connect my KUKA.Sim model directly to the behavior of the cell itself. And I could build my layout in KUKA.Sim, or I could import it, as I mentioned before. Now, this is used to test the functionality of my cell. However, it sometimes misses one point. I would probably need to create the behavior of the cell. For example, if I move an object on a conveyor, the PLC would put out speed to a frequency converter, for example. But I would like to know the position of this parcel, or simulate the position of this parcel or object on the conveyor belt. That is typically what is a feedback back to the simulation model. And there are some products, and if we stay with the Siemens example right now, they have a product called SIMIT, which is a virtual controller of the process response. That is, if I start moving an object on a conveyor, for example, the position of that object would be a feedback from the process. This could be fed back into the model, into the visualization, and hereby we can test such the functionality that the logic is working as it is meant to do, but I can also test various fault stages. So equally important of setting up a model, and before we run on, let's have a look at most of whether you're doing simulation or not, you actually are doing most of these cases. So it's not so much more work to do this model. Because if I go back one screen where we did not have the SIMIT, well, in a project you do the PLC and HMI code, you do the robot code. That means that the only add-on work you have to do to create a simulation is whatever layout you need to create in KUKA.Sim, which you probably have done in many cases according to the poll we did already. So connecting these environments together to really create a simulation is not that big of a work effort that you might suspect it is. You could use, in staying with this example, SIMIT to create the model of the behavior of the cell itself. This could, of course, be done in the PLC code or in the operator panel, but in many cases, customers don't want any code left in the PLC or robot system which purpose is for simulation. They want a clean project of doing this. So it's an easy way of putting in the behavior in some kind of simulation, process simulation tool. Now, what should we then simulate to be successful in our projects? Well, obviously, we want to debug our applications to ensure that we have a functioning model, of course. But equally important is actually to simulate various faults that could arise, both hardware faults or process faults in the process, to ensure that our application actually handles these in the correct way. Or can the cell easily be restarted again? One common fault is when you have safe signal exchange with neighboring cells, and we have a safety stop pressed in one cell, which causes a safety stop in our cell. How to reset that? I've seen myself examples of where we do lock up two cells without really having a good way of resetting them. This simulation can avoid. And perhaps even equally important is to let the customer's operator try out your user interface. Because often the programmer who has created the user interface has an idea of how the operator should behave. But when it comes to reality, the operator doesn't behave that way. And thereby ending up in strange scenarios of situation which the programmer hasn't really planned for. So letting the operator itself try the model or the simulation model is in many times very, very effective. So besides of allowing you to now download the KUKA.Sim software, we should point out that KUKA is a completely open system. So in many cases, you are already using other types of softwares, other PLC brands, for example, but also other CAD systems. The setup I showed you is actually an open setup, so we could actually combine it with products from any manufacturer. Could be from the PLC side, it could be the big players are Beckhoff and Allen Bradley or Mitsubishi, for example. They have their own PLC simulators for sure. And thanks to the open interfaces of Office Lite and KUKA.Sim, it can be used together with this. There are a load of process simulation softwares. Simit is only one, WinMod is another, for example. There are many available. All these can be connected together with Office Lite. And even for the visualization, we have our own alternative, which is Visual Components, which is better than KUKA.Sim to handle large cells with a complete line inside with many robots in it. But there are also possibilities to use NX, since I think some of you are already using NX to do their design of the cell. So this is an open system, so the layout or the setup varies with your needs or your customer